So having established the information processes supporting semantic memory, let's have a look at some specific semantic memory phenomena. Once again, we'll focus attention on the two cortical areas, an area detecting receptive fields effective for discriminating between different visual objects, and an area detecting receptive fields effective for discriminating between different spoken words. So, if a subject is shown a visual image and asked if it belongs to a named category, receptive fields will be directly detected in both areas within those sensory inputs. And the auditory receptive fields have recommendation strings in favor of indirect activation of visual columns on the basis of frequent past simultaneous activity. I'll show the visual area twice to avoid confusion. There'll be an indirect activation in that same area in response to hearing the word. It'll be in the same area, but the two populations will be maintained at different phases of frequency modulation to avoid confusion of information. If there's substantial overlap between the direct and the indirect activations, that circumstance or condition can be used to recommend saying that the visual instance belongs to the category. On the other hand, in response to the same verbal question when being shown a cat picture, there's relatively little overlap between the directly and indirectly activated populations, and the condition little overlap can recommend saying no. At the bottom, the total activity in each column, including both direct and indirect activations, is shown together for one visual area. There's stronger activity in the overlapping columns, indicated by the darker red. In the case of the cat, there are more columns active, but with weaker activity individually. So when the object is a member of the target category, there are fewer active columns with a larger average activity. When not a member, there are more active columns with a smaller average activity. So if in some other cortical area, some columns fire if there's a high level of spikes from a smaller number of sources, and other columns fire only if there are inputs from more visual columns, then the receptive fields in this area can discriminate between the circumstances corresponding with category member and non-member, and that can therefore recommend the appropriate responses. But now let's think about a less clear-cut case, an atypical member of the category. In this case, there's intermediate overlap, and no predominant recommendation exists. How can the brain identify the most appropriate behavior here? Well, there's some additional information that could be available. These are the receptive fields directly detected within current visual inputs from the ostrich. But in past brain experience, these columns have been active on other occasions. Think about past visual experiences of birds. The column indicated in purple isn't currently active, but as indicated by the green arrow, during a past experience it was active. And at that time, one of the columns in the current ostrich experience was also active. So that current ostrich column could have some weak recommendation strength in favor of indirectly activating that column indicated by the purple arrow. Since that's only one occurrence, I'll label that strength 1 at the bottom under the column. The next column is already active with the ostrich response. The third column is inactive in this current ostrich response, but it's been active in the past a number of times in different experiences. In the top one of those past experiences, when that column was active, one of the currently active ostrich columns was also active. In the second experience, it was active at the same time as 3 of the current ostrich columns. And in that bottom experience, it was active at the same time as 2 of the currently active ostrich columns. So that's a total of 6 sources of recommendation in favour of indirect activation of the column indicated in purple on the basis of past activity simultaneous with the currently active columns. You can go through that process for each inactive column, counting the past simultaneous activation frequency, and each time you get a possible weight in favour of indirect activation of the column. So if you look at all the numbers, in this simple conceptual example, there are 3 columns that are not currently detecting their receptive fields, but could be recommended for indirect activation on the basis of frequent activity in the past at the same time as the currently active ostrich columns. So if there's a second stage of indirect activation, several more columns will be indirectly activated. Now in practice, some of the currently active columns might cease being active unless they were also recommended for indirect activation. But leaving that aside, without the second indirect activation, the overlap is ambiguous. But once the second stage indirectly activated columns are added, there's a lot more overlap. So, with a slight time delay to allow for a second stage of indirect activation, the brain can get sufficient overlap to recommend saying the ostrich is a bird. And that's what we observe. Clear category members and clear non-members are classified in the same amount of time, but atypical category members take a little bit longer.